We have 10 minutes, and I'd like to focus on one thing, at least to begin with. You were involved with the previous speaker. In some way, you're an advocate for one of the grantees.
Yeah.
Your specialty is cancer. And we chatted on the phone the other day, and the subject that came up that intrigues me is that, maybe 10, 15 years ago, before I started doing a few books on healthcare, I thought, cancer was maybe one or two kinds of cancer, and as Laura said, well, there's lung and brain and there's the body parts of cancer, and she did mention, no, we're going to start looking at the tumor itself. And I remember in Philly, Richard Rockefeller, you know Richard, don't you?
Yes.
We were talking about Gleevec, because he was at one point on Gleevec.
Wonder drug.
Yep, the wonder drug, which was a drug that was focused on a cancer, which now they use for other cancers too, but it was designed in Cold Spring or something for that. Then they started designing other focused drugs for certain kinds of cancers, and I thought, well, read up, and they were talking about 103 kinds of cancer at one time. Then I started talking to you, and you said, no, it's a completely different story. Could you tell me that story a little bit?
I can do that. I'd like to first thank Laura for having the common sense to making us part of the winning team. And since it's really run as a business just for you in the audience, it's also unique because every team has an advocate, and nobody's going to push the research faster than the advocate. And I think that's just terrific. And Team I'm on is at Hopkins, Princeton, Harvard, and Penn. If we were sitting here when I started medical school in the 70s, the textbooks would say there are about 200 cell types. Therefore, there are probably about 200 types of cancer. Based on what we've done in rejuvenating medicine and all that we've done since Tuesday, and you heard from the genome that we are all different, I could submit to you in the next 5 or 6 minutes, there's a lot more than even 200 cancers. But I'd like to put it in perspective as a problem first, because since everybody's picking on you a little bit, I want to quiz the audience a little bit about why cancer is such a problem. You saw the embryo. We've been talking about genomes. You heard Craig talk about his making a gene with a single cell. Let's put the scale. We've heard about billions of cell phones. That one bug that you heard from Dr. Venter had about 500,000 of those building blocks for DNA, one cell. You, Rich, are 100 trillion cells, and each one of them has 3 billion of those building blocks. So theoretically, there's 10 to the 23 chances to make a mistake. The other point, when you think of cancer as a mistake in growth, and you saw the skin, you saw this regeneration, that's terrific. That's the good. The ugly is when this cancer grows out of control. And there's a lot of chances for that to grow out of control over the 70 or 80 years we're going to live. Because of your 100 trillion cells, every day you make and break about 500 billion. And I did a fast calculation. That means every second you are sitting here, you are making 100 to 200 million cells, whether it's skin, blood, your intestinal lining. That's a lot of chances for mistakes, because those 200 million cells are each doing 3 billion reassemblies. Mother Nature is still the best machine, and this is the argument I have with my brother all the time. Mother Nature's pretty cool. You realize she's been doing it for about 6 billion years, but it's very good. When the cells grow out of control, it's cancer. You heard David say the other day that cancer is a state. I absolutely agree with him. You can't look under a microscope and say one cell is cancer. First of all, I don't treat cancer, we treat people. And the cancer is really a tissue. There's inflammatory cells because the body's trying to get rid of it. How you react to that lump causes a cancer. It's a total body disease. So if you accept the proposition that we are all different, how we react to our cancer is all different, and we know even from molecular biology looking at lymphomas that we have at least 200 kinds under the microscope molecularly. I would submit that with the 15 million cancer patients diagnosed in the world this year, we probably have 15 million different cancers, because no two are really the same. Now, as a pediatric oncologist, I have to admit that I am both a sore loser, and I'm an optimist because in pediatrics we win about 75% of the time, but the cost is large, so we still need a lot better, safer, targeted magic bullets. But I'm a sore loser because we're not winning all the time. The adult cancers take longer. We need to work harder, and there are many, many cancers to fix.
Of those 100 trillion, 100...
You are 100 trillion cells.
100 trillion.
Yeah.
I thought about 90% of them were non-human cells, were just...
No, that 100 trillion is just you. You saw the bacteria on that mouth.
Yeah.
I would also remind you that you have more bacteria in you than you do your normal cells.
Most of it is not human. Most of it is other animals.
The 100 trillion cells are just you. If I added up
Right.
the bacteria, it would be astronomically large.
Okay. Because most of us, we are a zoo in that sense.
You're a zoo, but
Right.
you with your skin cells and your fibroblasts and your muscle cells and your heart cells and your brain cells and your hormone cells, yeah, you are 100 trillion. When you think about how fast normal cells grow, you know, that one egg you saw, do you realize in 9 months what it turns into? When you saw that growth rate, would have been 1.5 tons. It's really cool that Mother Nature almost does it right all the time. It's when it gets out of hand, we have this problem called cancer.
So you are not the only person who's talking about things getting out of hand,
Mm-hmm.
the triggering. Is there a focus on triggering mechanisms of
Yes.
what makes it get out of hand?
Yeah, I'm getting a little senile, and I was trying to say I was an optimist. So some of you now may be pessimists. How can we treat 15 million different cancers? The point is, and this is one of the stand-up projects, there's enough commonality because whether a director, the so-called oncogene is upregulated or suppressor gene is missing, at some point there is a final common path. And the final common path is how you're going to make the DNA. Are the conditions right for growing? And the tumor is very good at taking advantage of that. But you still need the gas, you still need the energy, you still need these basic pathways. So if you look at the drugs that are surfacing now, they are hitting the final common path. So even if they're all different, we use it. You heard Dr. Agus, when you say, well, the Taxol didn't work the first time, but he gave it one large dose, and 3 weeks later he gave some more. And then it stopped working. So then he gave it once a week, and it started working. Then he started giving it by infusion. I would submit that most of our cancer therapy is not quite right yet, because if you give a large dose and have to wait 3 weeks, it won't work. What we're learning with new drugs and old drugs, that a little bit every day, and that's what we've been doing in pediatrics for 30 years, works. You find the smallest amount it works, and we can keep this disease under control. And that's what we're learning in the last 2 decades.
Bart, what do we do to preserve that experience that you just described, giving some, and then giving much more, and then giving it more frequently? How is each of these many, many interactions and stories, how is it preserved so that somebody can make use of it again in another situation that you might see parallel situations?
So on April 1st, 2000, made up a word called metronomic therapy. The metronome is that slow, steady piano. When you think about other cases in medicine where we win, if you have a seizure, you take the medicine every day. You don't take it once every 3 weeks. If you have blood pressure medicine, you take it every day. If you have diabetes, you need something every day. What we learned with the failing of the usual high dose is that the tumor cells can hide. They're in the microenvironment that you heard. I don't even know whether I'm killing the cancer cell or the fibroblast or the endothelial cell, or whether I'm actually turning on the immune system. And you heard Dr. Blackkeith say, I'm getting the immune. This low-dose chemo is modulating the body, and it's allowing us to give treatment every day as an outpatient in a much kinder way, and we're beginning to see some results because we're not hurting the body as much as the standard routine therapy.
But Bart, I'm a schlepper. I live in Newport, Rhode Island. How do I know my doctors know that, or a doctor someplace else knows that? How can doctors keep up on these histories and these experiences so that they understand that anywhere, anytime, let's even say within the United States? Or can it not be done?
So 20 years ago, we had our association meetings, and I should say this is the best scientific meeting I've been to in a long time, because the IQ... The IQ in this room is great. You know what? In my business, it's called translational, because I'm learning from NASA engineers who are going to help me go through a proteome. I'm talking to people who know how to advertise to get messages out. This is just a terrific group. The way we learn, if pre-Google and pre the internet, was you read and you go to meetings and you publish things. We have instant publications now, we have meetings, we have word of mouth. I think for some cancers, again, I'll be fairly bold, I believe that some cancers have patients, because we don't treat disease, have such a poor outcome that I think the standard of care actually ought to be at a university on a clinical trial. If I looked at you and I said, Rich, you had AML, that's acute myeloid leukemia. There are some that have genetic changes where we have a 90% cure rate using arsenic and vitamin A, just like arsenic and Olase. And then we have some which are so bad that since we're all over, we won't say how old we are.
I've said how old I am.
Yeah, we're over 60.
How old are you?
I'm old as 60. I'm Dean's older brother, not his younger brother, and I'm not his stunt double.
How old are you?
61.
74.
Okay, so you and I are in the age group where if we got the wrong kind of acute myelogenous leukemia, half the patients over 65 aren't even treated because the docs don't think there's anything that's useful. You should have the right to get some treatment. On the other hand, right?
At least before next October.
And the other point with that is, if I did treat you with the standard medicine in the usual way, the statistics would say you have about a 3%, 5% chance of living 2 years. So I would submit that when the best known therapy given by anybody, a university professor or a community doc or a nurse, I don't care who gives it, it won't work. I would submit to you that your best chance for cure is a new agent or under the care of a physician trying something novel. When the best available therapy, you use 4-letter words, if the best available therapy sucks, go and get something better. Go look for something. That's your privilege and your right.
We're over our time. This is a very good format of talking to people and finding out things. And I'm going to stop this here because we're running late. But I would like to continue this conversation later. And next year, we should have more conversations because I think I'm learning a lot more sometimes than some people giving speeches.
Well, it's a privilege to be here.
And it's lovely to meet you.
Terrific.